Hello and welcome to a GCSE Maths practice paper walkthrough, and this is going to be for the 2024 exams, which are coming up in a couple of weeks' time. And this is going to be paper 1, which is non-calculator, and this is the foundation tier. But don't worry, if you are doing the higher tier, I am going to do a video for that as well. So just please take a look at my channel and have a search for the higher tier paper if you're doing that one. So in the video description, I've put a link to this paper. So what I would recommend you do is click on that link and go through all of the questions in the paper. And then when you've finished, come back to the video and we can go through the answers together. And also in the video, you can see chapter headings along the bottom. So if you are stuck on a particular question, you can just skip along to that question and I'll go through the answer. So without further ado, let's get cracking with question number 1. So question 1, part A, change 0.9 kilograms into grams. So for this one, we need to know our conversions between grams and kilograms, and there are 1,000 grams in a kilogram. So 1 kilogram is equal to 1,000 grams. So to go from kilograms to grams, well, we're just going to multiply it by 1,000. Always make sure you're doing the correct operation and not divide for this one. So for kilograms to grams, we are multiplying by 1,000. So we're going to do 0.9 multiplied by 1,000. Remember, this is non-calculator, so all we need to do is move the decimal point to the right 3 times. So if I do it once, that will give me 9. Twice will be 90. 3 times is 900. So our answer for this one is 900. And we don't need to write our units for this. If you did put G for grams, that's absolutely fine, but we don't need to. Okay, moving on to part B. Change 2,840 meters into kilometers. So again, with our conversions, we are going from meters to kilometers. Now there are 1,000 meters in a kilometer. So 1 kilometer is equal to 1,000 meters. Similar to this one. So we've got kilo. Kilo means 1,000. So this time we're going the other way because we want to know, we're going from meters to kilometers. So to go from meters to kilometers, this time we're going to be dividing by 1,000. So it's going to be 2,840 divided by 1,000. So our decimal point is here. We're just going to move the decimal point to the left this time 3 times. So 1, 2, 3. Now our decimal point is here. So our answer is 2.84. We don't need that 0. So 2.84 is the answer. Question number 2. Work out 30 subtract 9 multiplied by 2. Now we need to think really carefully about this because we've got our orders of operation. So whenever we've got a subtraction and a multiplication in the same calculation, we always do the multiplication first. So I like to remember BIDMAS. So BIDMAS. You might have been told something else in your school, but this is how I like to remember it. So brackets always come first, then indices, and then division and multiplication. These have the same priority. We just do it from left to right. And then addition and subtraction also have the same priority, and they come last. So if we look at our calculation, we've got a multiplication and we've got a subtraction. So you can see that multiplication has a higher priority, so we're going to do this bit first. So we're going to work out what 9 times 2 is first. So 9 times 2, well, that will give us 18. So now we've just got 30 subtract 18, and that is going to give us our answer. And that is 12. So our answer is 12. Question number 3, we need to solve this equation. So we've got 8 subtract something is equal to 3. Well, straight away, I can see that our answer is going to be 5. X is going to equal 5 because I know that 8 minus 5 is equal to 3. But if we were to do it systematically, let's just show you, if we did have a slightly harder one, let's go through how I would solve this. So ultimately we want to get x on its own. So our final line of our working should be x equals something. Now at the moment we've got this minus x here. So what I'm going to do is I'm just going to put the x on the right hand side just so it's not negative. So what I'm going to do is I'm going to add x to both sides. Remember, if I'm adding x to one side, I have to do exactly the same to the other side because we've got an equation. Whatever we do to one side of an equation, we have to do exactly the same to the other. So what are we left with? Well, on the left-hand side, we've just got 8 because minus x plus x, those two things will just cancel out with each other. And on the right-hand side, we've got 3 plus x, or I could say x plus 3. And now, just to get x on its own, because that's what we want x on its own, I'm just going to get rid of this 3. So to get rid of 3, we're just going to do the opposite. So I'm going to subtract 3. And remember, whatever I do to one side of an equation, I have to do the same to the other. So I'm going to subtract 3 from the left-hand side. So now on the left-hand side, I've got 8 minus 3, which is 5. And on the right-hand side, these 3's cancel out. Plus 3 minus 3 is just 0. And all we're left with is x. So we've got 5 is equal to x, or x is equal to 5. So our answer is 5. And for this particular question, like I said, I could just see straight away that 8 minus 5 equals 3. But it's definitely handy going through this process when we get slightly trickier equations, which I'm sure we will later on in the paper. Question 4. Below are 7 cards, each with a number written on it, which we can see over here. Choose 2 suitable cards to make the calculation correct. And our calculation is something plus something is equal to 2. So we need to find 2 numbers. When we add them together, we get 2. So if we've got negative 3 in one of them, negative 3, what do we need to add to negative 3 to get 2? Well, we need to add 5. But there is no 5, so we can't use negative 3. What about negative 4? So negative 4 plus something equals 2, or negative 4 plus 6 equals 2. And I can see that there is a 6 here. So I'm going to say negative 4 plus 6. So I'm going to use these 2 cards, and that will give me the correct answer. Now let's just see if any of the other ones work. So if we had 2 here, 2 plus what equals 2? Well, 2 plus 0 equals 2, so we can't use that one because there's no 0. So those 2 are both going to be crossed out. 4, what do we need to add to 4 to get 2? Well, 4 minus 2 equals 2, so it would be negative 2, but there's no negative 2, so we can't use 4. Negative 7. Negative 7 plus 9 would give us 2, and there's no 9, so we can't use negative 7. And then by default, we can't use 1 because there's nothing else to pair up with 1. So the answer, there is only one set of numbers, negative 4 and 6. Question number 5. A sequence of numbers starts at 15 and follows the rule treble the last number and add 4. And this is our sequence. The number 4129 is in the sequence. Calculate the number which comes immediately before 4129 in the sequence. So we've got our sequence down here. And I'm not sure what the next number is, but we get to some number where the following number in the sequence is 4129, and we need to calculate the number immediately before this number. So what is this number here? So let me just write it down here. So we've got some number, and then if we follow the rule, we are trebling the last number and adding 4. So we're going to multiply this number by 3, and then we're going to add on 4, and that gives us this number here, which is 4129. So we're working backwards to work out the number that comes before it. So what we can do is we can just apply the rule, but in reverse. So if you notice, the last thing we're doing is adding 4. So if we go backwards, what we can do is we can subtract 4. And then instead of multiplying by 3, because we're going backwards, we're going to divide by 3. So let's do that. We're starting off with 4129. And we're going to subtract 4. So 4129 subtract 4. Well, that will give us 4125. And then we need to divide by 3. So I'm just going to do 3's into 4125. So 3 goes into 4 once with 1 remainder. 3 goes into 11 3 times with 2 remainder. 3 goes into 22 7 times. 7 times 3 is 21, so we're going to have 1 remainder. And then 3 goes into 15 exactly 5 times. So the number that comes before 4129 is going to be 1375. Now there is another way you could have done this. You could have gone forwards. So if you'd started off with 457 and just applied this rule, so treble the number and add 4, you would have also got to 1375. So 2 ways you could have done it. The reason I did it this way is because I didn't know that this number was actually the next number in the sequence. This we could have kept going on and on and on and on and on. Whereas if doing it in reverse, I know that the very next number we find will be the number we're looking for. So either way, our final answer is going to be 1375. Question number 6. Shown is a rectangle, and we've got these dimensions here given as expressions. We're told the perimeter of the rectangle is P. We need to find a formula for P in terms of X. So we're told that the perimeter of the rectangle is P. So P is going to be equal to this length plus this length plus this length plus this length. Now, because this is a rectangle, we know that opposite sides in a rectangle are equal. So if this length here is 2x plus 7, well, this length must also be 2x plus 7. And likewise, if this length is x plus 3, well, this length is also going to be x plus 3 because they are the same. So the perimeter is the entire distance around the outside. So all I'm going to do is add up all of the lengths. So it's going to be this length, which is 2x plus 7, plus this length, which is another 2x plus 7, plus this length, which is plus x plus 3, and then plus this length, which is also x plus 3. So quite a lot going on here. So we found an expression where we've written out a formula for P in terms of x, because these are all x's and numbers here, but we can simplify that, and the examiner will definitely be looking for you to simplify this. So let's add up all of the x terms. We've got 2x here, and then we've got another plus 2x, and then plus x, and then plus x. So those are all my x terms. So 2x plus 2x is 4x, plus another x is 5x, plus another x is 6x. So we've got 6x, and then we just got the numbers. So we've got plus 7, plus another 7, plus 3, plus another 3. So 7 plus 7 is 14. That's going to be 17, 20. I think I've done that right. Yeah, 20. So plus 20. And we can't simplify this anymore. So my final answer, a formula for P. So P is equal to, and we need to write it in terms of x, and you can see that we have got it in terms of x. So it's going to be 6x plus 20, and that is my final answer. Question number 7. Part A, write down the coordinates of the point C. So this is the point C here. So we need to write down the coordinates. So whenever you're writing down coordinates, how I like to remember the order is along the corridor up the stairs. So we always go along the x-axis first. So we're going 1, 2 to the left. So that's going to be -2. So that's our x-coordinate. And then we're coming down the stairs and we're going down 1. So it's going to be -1. So our coordinates are -2, -1. Okay, part B. ABCD is a rectangle. The point B has coordinates 3, -1. Plot the points B and D on the grid. So we're told that ABCD is a rectangle. So we've got 2 of the points of our rectangle. We've been given the third point. So point B has the coordinates 3, -1. So let's plot that. So we're going to go along 3 and down 1. So along 3 and down 1. So that point there is point B. And we're told that it is a rectangle, and we've got 3 of them. So if I just, you can see, if I were to just draw this in, obviously this is done without a ruler, but hopefully you can get the picture. To form a rectangle, our last point needs to be here. So if we just go up and along, you can see that we've got a rectangle. So that is obviously point D. And that's it for that part. It just says to plot the points on the grid. So we don't have to write down the coordinates. I've plotted B and D on the grid. Okay, now part C. On the grid, draw the line with the equation y equals -3. So we've got the line y equals -3. So let's just think about on our grid, where is the point y equals -3? Well, this is our y axis. So if we go down to -3, we can see that that is this point here. So y equals -3 is down here, but it doesn't matter what the x value is. The y is always going to be -3. So that point there that I've just marked, the y value is also -3. This point over here, the y value is also -3. So it doesn't matter what the x value is. Anywhere on this line, y will be -3. So that is going to be our line. So let me just draw that line in. That is the line. Or let me just make it a bit thinner. There we go. And let's just change it to red, just because I've been using red crosses. So this is the line. Y is equal to -3. A lot of people make the mistake of doing a vertical line. Because the y-axis is a vertical axis, they'll draw a vertical line, but you just need to be really careful. It's always the opposite. So if we had an equation where it said x equals, then that would be a vertical line. But this is a horizontal line at the point y equals -3. Question 8. The area of a football pitch is 6,040 meters squared. A hockey pitch is 91 meters long and 37 meters wide. Work out how much larger the area of the football pitch is than the area of the hockey pitch. So we've been told the area of the football pitch, which is 6,040. We need to work out the area of the hockey pitch. So how do we work out an area? Well, we do base times height, or length times width. So one of these is going to be 37, and the other dimension is going to be 91. So the area that we're interested in, we just multiply these numbers together. So it's going to be 91 times 37. And remember, we don't have a calculator, so I'm going to have to do this longhand. So I'm just going to do it over here. 91 times 37. So 1 times 7 is 7. 9 times 7 is 63. And now we're focusing on the 3. So we need to put a 0 here because this is the tens column. 3 times 1 is 3. And 3 times 9 is 27. And now we just add these together. 7 plus 0 is 7. 3 plus 3 is 6. 6 plus 7 is 13. Carry the 1. 2 plus 1 is 3. So the area of the hockey pitch is 3,367 meters squared. So remember, this is in meters, this is in meters, so our answer is in meters squared. Now the question says work out how much larger. So it doesn't say how many times larger. So because it says how much larger, we just need to subtract one from the other. So we can see the football pitch is bigger. So we're going to do 6,040 subtract 3,367. So 0 minus 7 we can't do. So let's borrow from the tens. That becomes a 3. That becomes a 10. 10 minus 7 is 3. Now 3 minus 6, we can't do that. So we can't borrow from the 0 because there's nothing there. So we're going to have to borrow from the thousands column. So that becomes a 5. And that becomes a 10. And now we can borrow. So obviously we still can't do the 3 minus 6. So we're going to have to borrow from the hundreds now. So this becomes a 9. It was 10. So now this is 9. And we put a 1 here. And now we've got 13 minus 6, which is 7. 9 minus 3 is 6. And 5 minus 3 is 2. So we've got our answer. So our answer, we don't need to put our units in. I'll write it here, but in the answer we can just put the number. So it's going to be 2,673 meters squared. Question 9. Using 3,068 divided by 26 is equal to 118, write down the answer to 3,068 divided by 52. So for this particular question, we're not asked to do the calculation itself longhand. So we're not supposed to do long division. We should just be able to work this out using this here. So we've got the same starting value. So you can see that they're both 3,068. Here we're dividing by 26 and here we're dividing by 52. Now the key thing to notice here is that 52 is twice the size of 26. So 26, if we multiply that by 2, we do get 52. So we're dividing by something that's twice the size. Now, let me just go through an easier example. Let's start with, let's say we had 8. So if we had 8 and we divided by 2, well, we know the answer is 4. Now, if we're dividing by something that is twice the size, so now let's divide by 4, well, we're going to get an answer that is half the original answer. So if we're dividing by something that's twice the size, our answer is going to be half the size. So if we're dividing by something twice the size, our answer is going to be half of whatever this is. Another way to think about it is we're cutting our 3,068. So this is what we're starting with. Here we're cutting it into 26 pieces. Here we're cutting it into 52 pieces. So because we're cutting it into more pieces, each piece is going to be half the size. So if we're dividing by 52, it's going to be half of 118. So it's going to be 118 over 2. So let's just work out what that is. So how many 2's go into 118? So 2 doesn't go into 1. 2 goes into 11 5 times with 1 remainder. And 2 goes into 18 9 times. So our answer is 59. Question 10. The number of passengers on 10 buses was recorded. The stem and leaf diagram shows this information. So here's our stem and leaf diagram, and we've got a key here. So it says 1-4 means 14 passengers. So on one of the buses, there was 7 passengers. So 07 would mean 7. On another bus, there was 9 passengers. On another bus, there was 14. On another bus, there was 15, etc. And we need to work out the median. So let's just remind ourselves what the median means. So the median is another way of saying the middle number. So we're going to be looking for the middle number. Now in our list, because this is a stem and leaf diagram, it's all in order. So the smallest number is 7 and the largest number is 30. So because they're all in order, we're just going to work our way until we get to the middle. So what I like to do is just cross off the numbers. So cross off 7 and 0, then cross off 9 and 23. Sorry, when I said 0, I should have said 30. And then cross off 14 and 21, 15 and 18. And then in the middle, you can see we've got 16 and 18. Now, when we have two numbers in the middle, we pick the mean of those two numbers. So we've got 16 and we've got 18. So to calculate the mean, we could add them together and divide by 2, but I can just see that the mean is going to be 17. So the median is going to be 17 passengers. Okay, let's look at part B. A bus is selected at random. What is the probability the bus has more than 20 passengers? Okay, so how many buses have more than 20 passengers? Let's circle them. So none of these ones up here. So this one, 21 passengers. This one's got 23 passengers. And this one's got 30 passengers. So there are 3 buses that have over 20 passengers. Out of the total number of buses, well, we know there's 10 buses. We're told there's 10. You could count these up, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we're told there's 10. So 10 buses in total. So the probability is just going to be 3 divided by 10. 3 over 10. And it doesn't matter how we write it. We could write it as a decimal, 0.3, or we could write it as a percentage. So all three of these would be acceptable. Let me just write it as a percentage. Okay, doesn't matter which one you put, these are identical. If it said in the question, what is the probability, write your answer as a percentage, then we would need to give this answer, but it doesn't matter for this question. Question 11. 465 fans want to go to a rugby match. Each bus holds 50 fans. Work out the number of buses needed. So we've got 465 fans and each bus holds 50 fans. So we could do 465 divided by 50, or I think probably the easier way is just to go up in 50s. So we've got, that would be one bus. 2 buses can hold 100. 3 buses can hold 150. And then I'm just going to keep going up in 50s until I get to my magic number. So 300, 350, 400, 450. Now we're not quite there. We've got 465 fans. So we can't leave some fans behind. We need to take all of them. So we're going to have to go up to 500. So this last bus is going to have a lot of empty space. So that's probably good for rugby fans if they're getting a bit drunk after the match. But we need all of these buses. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer is 10. Okay, part B. 11 fans decide not to go to the match. How does this affect the number of buses needed? So does it affect the number of buses needed? Well, we said that 10 buses hold 500 fans. We've got 465 fans. So we're starting off with 465 fans. If we take away 11 fans, so 11 fans are not going to the match, how many does that leave us with? Well, that's going to leave us with 454 fans. Now, do we need to reduce the number of buses? Well, no, we don't, because if we went with 9, let's say we had 9 buses, 9 buses can only hold 450 fans, and we've got 4 more than that. So those 4 extra fans are going to be left behind, and I don't think we're allowed to leave fans behind for this particular question. So we need to take all the fans, so those 4 fans will have to go on the next bus, that 10th bus. So we can't reduce the number of buses. So I'm just going to write, it doesn't change, 10 still required. It's only 1 mark, so I don't need to put anything more than that. I can just say it doesn't change, 10 is still required. Question 12. 150 students in years 10 and 11 visit a school canteen. Some students have packed lunches. Some students have a cooked lunch. 56 out of the 89 students who have a packed lunch are in year 10, and there are 72 year 11 students. Work out how many year 10 students have a cooked lunch. So there's a lot of information here. Now we've got 2 different categories. We've got the year group, so years 10 and 11, and the type of lunch. So we've got the packed lunch and the cooked lunch. So what I'm going to do is I'm going to put this into a 2-way table. So let me just show you what I mean by this. So we've got year 10 and we've got year 11. So I'm going to put that down one side, and then down this side I'm going to put the type of lunch. So I'm going to put packed and cooked, just like that. And I'm actually also going to put one more, which is the total. So this is called a 2-way table, and it just helps to organize all of the data. So if I go through everything, there are 150 students in years 10 and 11. So the total is going to be 150. So that is the grand total, 150 students. Now, 56 out of the 89 students who have a packed lunch are in year 10. So there's 89 students who have a packed lunch. So if we look at the packed lunch, the total is going to be 89. That's the total number of people who have a packed lunch. And we're told that 56 are in year 10. So we can write 56 there. Now, straight away, we can work out how many students in year 11 have a packed lunch, but just by doing 89 minus 56. So 89 minus 56. 9 minus 6 is 3. 8 minus 5 is 3. So there's going to be 33 students in year 11 who have a packed lunch. Okay, let's look at the next part. There are 72 year 11 students. So this time we're going to look at the column, and in year 11 there are 72 students in total. So now we can work out how many students in year 11 have a cooked lunch, and that is actually what it's asking us in the question. It says work out how many, oh no it doesn't, work out how many year 10 students. So we're not there yet, we're going to have to get there eventually, but first of all I'm going to work out this box here. So the number of year 11 students who have a cooked lunch is going to be 72 minus 33. So 2 minus 3 we can't do, so borrow from that, that becomes a 6. And that becomes a 12. 12 minus 3 is 9, and 6 minus 3 is 3. So there's 39. Now, I can also work out this category here just by doing exactly the same thing. 150 minus 89. So 0 minus 9, we can't do that, so let's borrow. That becomes a 4. That becomes a 1, or a 10. 10 minus 9 is 1. Now, we can't do this, so we're going to have to borrow from the hundreds, so that becomes a 0, that becomes a 1. So 14 minus 8 is 6, and 0 minus 0 is 0. So we're left with 61. And now we've got these two, we can work out this one here, and that is what it's asking us for. So this time we've got 61 students in total who had a cooked breakfast, or a cooked lunch, I should say. 39 of those were year 11, so we're just going to subtract 61 minus 39. So again, we can't do this, so let's borrow. That becomes a 5, that becomes 11. 11 minus 9 is 2. 5 minus 3 is 2. So it is 22. We don't need to work out this last one. So the key number is this one here. How many year 10 students have a cooked lunch? The answer is 22. So there's many more ways you could have done this. I just like to use a two-way table just because it helps me organise all of the data. And I just go through each line step by step, and you should hopefully get the answer that you're looking for. Question 13. The volume of a cube is 125 centimetres cubed. Work out the surface area of the cube. So let's just do ourselves a drawing. So our cube, and this is obviously not to scale, this is just a sketch. So I'm just doing a sketch of a cube. Okay, and actually let's just do the dashed lines. It's a terrible drawing, but hopefully it doesn't matter too much. So we know the volume is 125 centimetres cubed. So first of all, let's work out what each side length is. So how do we calculate the volume of a cube? So we do the width times the depth times the height. So volume is equal to width times depth times height. You could say length, but it doesn't really matter for this. So, and because this is a cube, we know that all three of these are the same, exactly the same number. So something, we've got something times something times something is equal to 125 centimetres cubed. And we know that these are all the same. So what number can we get? We don't have a calculator. It's obviously not going to be 1. 1 times 1 times 1 is just 1. 2 times 2 times 2, well, that will give us 8. If we had 3, 3 times 3 is 9. 9 times 3 is 27. 4, so if we had 4, 4 times 4, well, that will give us 16. And then 16 times 4 is definitely not 125. I think that's 64 centimeters cubed. So it's not 4. Let's try 5. So 5 times 5, well, that will give us 25. And then 25 times 5 does give us 125. And we can just prove that to ourselves. 25 times 5. 5 times 5 is 25. And then 2 times 5 is 10. 10 plus 2 is 12. So you can see it is 125. So now we know that each side length is 5 centimeters. So now we can calculate the surface area. So what is surface area? Well, surface area, we just need to calculate the area of each of the faces. So each of the faces, there are 6 faces in a cube. So so the left, the right, the top, the bottom, the front, and the back. So there's 6. And remember, the key thing is they're all going to be the same because this is a cube. So we can just calculate the area of one of them. So let's just do this one because I've highlighted it. So we know that these are all 5. So this area here, just do it in red, is going to be 5 times 5. It's going to be 5 times 5. 5 times 5, and that gives us 25 centimeters squared. So that's the area of one face, but we've got 6 of them, so let's just multiply this by 6. So 25 times 6, 5 times 6 is 30, 2 times 6 is 12, plus 3 is 15, and we get 150. So our answer, excuse me, is 150 centimeters squared. Question 14. We've been given 4 fractions here, and we need to write these fractions in order, starting with the smallest. Now, whenever you're asked to write fractions in order, the key thing here is to get a common denominator. So you can see our denominators are all different. So what is the lowest common multiple of all of these numbers? So we've got 4, 8, and 16. So the lowest common multiple is in fact 16. Look, 4 goes into 16 4 times, 8 goes into 16 twice, and 16 goes into 16 once. So we can use 16 as our denominator for all of these fractions. So we've got 13 out of 16. We don't need to change that one. We've got 3/4. Now 3/4, if I'm converting that into another fraction, an equivalent fraction, where my denominator is 16, what is my numerator going to be? Well, to go from 4 to 16, I'm multiplying by 4. So I just need to do exactly the same with my numerator. 3 times 4 is 12. So 3/4 and 12 over 16 are the same thing. So we've got 12 over 16. The next number is 5 over 8, 5/8. And again, I'm going to do exactly the same thing. So if my denominator is 16, this time I am multiplying by 2. So I'm going to multiply my numerator by 2. 5 times 2 is 10. So we've got 10 over 16. And finally, the last one, we don't need to do anything with that. It's nice and easy. We can just keep that as 11 over 16. So now we've got all of our fractions with the same denominator. We can look at which one of these is the smallest. So the smallest is going to be this one here. So 10 over 16. But be careful, don't write 10 over 16 here. Write the one that was the number that was given to you. So that was 5/8. So 5/8 was the smallest. And then we've got 11 over 16, and that was 11 over 16. That was written like that originally. Then we've got 12 over 16, but that was 3/4. And then the largest is 13 over 16, which was how it was given, 13 over 16. So key with this question is to find a common denominator. It doesn't always need to be the lowest common multiple, but if we're dealing with as smaller numbers as possible, that's probably the easiest way to go. Question 15. 1,935 people visit a library during 1 week. The ratio of children to adults is 1 to 4. How many more adults than children visited the library? So we know the total number of people that visited the library, and we know the ratio. So we've got 1 part children and 4 parts adults. So the total number of parts, so total parts, well, we can just add these two together, 1 plus 4, so that gives us 5. So now we can split these 1,935 people into 5 parts. So I'm going to do 5s into 1,935. So 5 doesn't go into 1. 5 goes into 19 3 times with 4 remainder. 5 goes into 45 8 times. 8 times 5 is 40. That gives us a 3 remainder. And 5 goes nicely into 35 7 times. So there is 387 people for each part. So let's work out the number of children. So the number of children, well, that's going to be 1 times 387. So that's nice and easy. That's just 387. And then the number of adults, well, there are 4 parts adults. So we're going to do 4 times 387. Let me just do that up here. 387 times 4. 7 times 4 is 28. 8 times 4 is 32. Plus the 2 is 34. And 3 times 4 is 12. Plus the 3 is 15. So we've got 1,548. Now, if we read the question, it says, how many more adults than children visited the library? So we just need to subtract. So we just need to do 1,548 minus 387. So 8 minus 7 is 1. 4 minus 8 we can't do, so let's borrow from the 5. That becomes a 4. And now we've got 14 minus 8, which is 6. 4 minus 3 is 1. 1 minus 0 is 1. So we have our answer, 1,161. Question 16. Candles normally cost £6 each, and 2 websites have special offers. The first one, Co-ordinates candles, we've got a buy 3 get 1 free offer, and candles for us, we've got 20% off. Laura wants to buy 30 candles in total, so which website should Laura use? So let's go through each offer. Let's first of all start with Co-ordinates candles. So for every 3 that she pays for, she gets 1 free. So if she buys 3 lots of candles, she's getting 4 candles because she's getting 1 free. So if we do 3 times £6, so if she's buying 3 candles for £6 each, that's going to be £18. But that's going to give her 4 candles because she's getting 1 free. So I'm just going to write equals 4 candles. So if she pays for another set of 3, well, that's going to be £36, and that's going to give her 8 candles. So all I'm doing is I'm doing this exactly the same thing. So I'm imagining she's paying for 3 and she's getting 1 free. So every time she pays for 3 candles, it's costing her £18 and she's getting 4 candles. So we need to get up to 30. So if we keep adding on 18, that's going to take us to £54, and that's going to be 12 candles. And then add on 18 again, that's going to take us to £72, which is going to be 16 candles. There might be a different way of doing this, but this is the way I'm choosing to do it. So add on another 18, that's going to take us to £90, and that's going to be for 20 candles. And then 18 again, that's going to be £108, and that's going to give us 24 candles. Add on 18, we're going to get to £126, and that's going to be 28 candles. Now, you need to be careful here, because if we do it again, we're going to get 32 candles. We don't need 32 candles, we only need 30 candles. So now we can't use this offer anymore of buying 3 and get 1 free. We're just going to have to buy 2 extra candles. So we're going to buy 2 extra candles to get us to 30 candles. Now, how much is it going to cost extra for 2 extra candles? Well, they're £6 each, so it's going to be £12. So if I'm just going to write here plus £12. So what's that going to take us to? That's going to take us to £138. So it's going to cost £138 from BIDMAS candles. Now let's look at Candles R Us. So this is slightly different because we've just got a 20% off deal. So if we buy 30 candles for £6 and then take 20% off, let's see what we're left with. So we can do 30 times 6. So 30 candles, £6 each. That's going to give us £180. But then we know that they get 20% off. So 20% off 18. There's a few ways we could do this. We could divide it by 5. Or we could multiply by 0.2. I think I'm going to divide by 5. So, because I know that 20% is 1/5. So if we just divide by 5. So 5s into 18 go 3 times. 3 times 5 is 15. So we're left with 3. And 5s into 30 go 6 times. So 36, that is the discount she's getting. That's the 20% off. So to work out the total cost, we can just subtract 36 from 180. So we can do 180 minus 36. So we can't do 0 minus 6. So let's borrow. So that's a 7. That's a 10. 10 minus 6 is 4. 7 minus 3 is also 4. 1 minus 0 is 1. So it's going to cost £144 from Candles for Us. So it looks like the best deal is from BIDMAS candles. And let me just show you the other way of doing this. So instead of dividing by 5, we could have multiplied by 0.2. So we could have done 180 times 0.2. Well, I know that 180 times 2 is 360. But because we're multiplying by 0.2, we can just move the decimal point 1 to the right. So 180 times 0.2 will be 36, which is the same as what we've got over here. But the key thing is make sure we read the question. It says, which website should Laura use? So we can say Laura should use, I'm just going to put CC for short, BIDMAS candles. And as long as you've shown the two values, £138 and £144 as well, that will give you all 4 marks. Question 17. 2 bags, 1 and 2, each contain equal size counters. Bag 1 contains a pink, yellow and white counter, and bag 2 contains counters labelled 1, 4, 5 and 7. A counter is drawn at random from bag 1 and a counter is drawn at random from bag 2. If the counter from bag 1 is pink, the number on the counter from bag 2 is increased by 1. If the counter from bag 1 is yellow, the number on the counter from bag 2 is decreased by 5. And if the counter from bag 1 is white, the number is halved. We need to find the probability of scoring a number below 3. So we've got 2 bags. And first of all, we're going to choose from bag 1. We've got 3 different options. And then we're going to choose from bag 2. So if we choose from the yellow bag, we can either get a 7, 1, 5 or 4. But notice, if we choose from the yellow bag, each number is decreased by 5. So if we then pick a 7, well, that's going to correspond to a 2. If we pick a 1, well, that's going to correspond to a negative 4 because we're subtracting 5. If we pick a 4, that's going to correspond to a negative 1. And if we pick a 5, that's going to be 0. So I've just taken away 5 from each of these numbers. Now, what about if we pick a pink? If we pick a pink ball or a pink counter from bag 1, well, this time the pink counter means that anything from bag 2 is increased by 1. So the 7 will become an 8. The 4 will become a 5. The 1 will become a 2 and the 5 will become a 6. And then finally, if we pick a white from the first bag, what's happening? Well, each of these numbers is being halved. So the 7, that will become 3.5. The 4 will become a 2. The 1 will become a 0.5. And the 5 will become a 2.5. So we need to find the probability of scoring a number below 3. So let's go through all of these outcomes. Well, this one is below 3, this one is, this one is, this one is, this one's not, this one's not, this one is, this one's not, this one's not, this one is, and this one is. So we can see that there's 12 possible outcomes. So our denominator is going to be 12. And how many of these 12 are below 3? We've got 1, 2, 3, 4, 5, 6, 7, 8. So our answer is 8 out of 12. We can simplify this. We don't need to. We will get four marks for this. But if we did want to simplify it, both of these numbers are divisible by 4. So 8 divided by 4 is 2. And 12 divided by 4 is 3. So we could either say 8 over 12 or 2 over 3. Question 18. A farmer keeps cows, pigs, and sheep on his farm. The ratio of cows to pigs to sheep on the farm is 2 to 7 to 16. Work out the percentage of the animals that are sheep. So another ratio question here. So we've got the different parts of the ratio. I'm going to add up these to work out the total first of all. So if we do 2 plus 7 plus 16, so 2 plus 7 is 9, 9 plus 16 is 25. So there are 25 parts in total. Now we're asked for the percentage that are sheep. So if we look at the question says cows to pigs to sheep. So sheep is the last animal. So we always correspond with the ratio. So it's going to be the last number in the ratio. So it's going to be the 16. So sheep is going to be 16 out of 25. So out of 25 animals, 16 are sheep. And now we just need to write this as a percentage. Now the easiest way I can think of doing this is if we look at the denominator, we can see that's out of 25. Now percentages are always out of 100. If you think about the word percent, it means per 100. So we just need to find an equivalent fraction first of all, and then we'll be able to write that as a percentage. So to go from 25 to 100, well, we need to multiply that by 4. So if we do exactly the same with the numerator, 16 times 4, let's just do that over here, 16 times 4, 6 times 4 is 24, and 1 times 4 is 4, plus 2 is 6, that's 64. So you can see that it's 64 per 100, or we can say 64%. So that is our answer, 64%. Question 19. Donna uses this recipe for chili con carne, and this recipe serves 6 people. Donna is going to use this recipe to make chili con carne for 15 people. Work out how many grams of mince she needs. So we only need to focus on the mince. So this one here, we don't need to worry about all of the others. So this recipe is for 6 people. So 6 people is 1 kilogram of mince. And we need to work out 15 people. Okay, so how much mince is required for 15 people? Now to go from 6 to 15, a bit tricky, but we're going to be multiplying by 2.5. So if we did, let me just show you down here. If we multiplied by 2, that would give me 12. And if we multiplied by 3, that would give me 18. And 15 is exactly halfway between 12 and 18. So 6 times 2.5 is equal to 15. So we can multiply. So what we're doing is we are multiplying by 2.5. So if we do exactly the same to the other side, if we multiply by 2.5, well, that's going to give us 2.5 kilograms of mince. Now, be really careful here. Do not write 2.5 in here, because looking at the units on the answer line, it's in grams. And also in the question, it says work out how many grams. So I'm just going to really go crazy on that, because it's very important. We'll lose marks otherwise. So we need to convert from kilograms to grams. So 2.5 kilograms. Well, we just need to multiply it by 1,000. So it's going to be 2,500 grams. So there is another way you could do it. If you didn't know that we had to multiply by 2.5, what you could have done is you could have multiplied by 2 to give you 12 people, and then just added on an extra half to get to the 2.5 or the 15 people. So there's a few ways you could do it, but the answer we're looking for is 2,500 grams. Question 20. Write 5 million in standard form. So let's first of all write out the number in digits. So 5 million is 5,000,000. Now, whenever we're writing things in standard form, the base number always has to be between 1 and 10. So in this case, our base number is just going to be 5. And then we always multiply by 10 a certain number of times. So how many times are we multiplying by 10 to get to 5 million? Well, our decimal points is going to start here if we're at 5. And then we're going to go 1, 2, 3, 4, 5, 6 places to the right until we get to 5 million. So it's to the power 6. So that is our answer. 5 times 10 to the power 6. Okay, let's look at part B. A calculator displays a number in standard form, which we can see over here. Write the number as an ordinary number. So we need to go backwards this time. So our base number is 8.1. And now we're multiplying by 10 a negative number of times. So instead of moving our decimal point to the right, because we've got a negative power, we're going to be moving it to the left. We're going to be dividing by 10. So what I like to do is I just like to put some zeros here, just as placeholders. Okay, and now when we move our decimal point to the left this time, we're going 5 times. So we're going to go 1, 2, 3, 4, 5. So now it's going to be here. So we don't need this last 0. So this is our answer. So it's going to be 0 point, and then we've got 1, 2, 3, 4 zeros. 0, 0, 0, 0, and then 8, 1. So that is my answer. Question 21. Round 45.2807 to 2 significant figures. So a lot of people always struggle with significant figures, but let's write this number down. 45.2807. So in our number, the first significant figure is this one here. Okay, the first decimal point would be here. If we were rounding it to 2 decimal places, we'd start here. That would be our first one, that would be our second one. But significant figures is the first non-zero number. So that is our first significant figure. That is our second significant figure. So let's just put a dash there. So what we need to do is look at the one after that, look at this number, and if it's less than 5, this would stay at 45, and if it's greater than 5, we'd round this up to 46, but we can see that this is clearly less than 5, so it just stays at 45. So our answer is just 45. Question 22. Work out 1 2/9 divided by 3/4. Now, before I go any further, I'm just going to convert this mixed number into an improper fraction, just because I find it much easier dealing with improper fractions. So 1 2/9, well, that is equivalent to, so if we do 1 times 9, that's 9 plus 2 is 11. So that gives me 11/9. So now we've got 11/9 divided by 3/4. So these are exactly the same thing. Now, whenever you're dividing by a fraction, that's the same as multiplying by its inverse. Or you might have heard the term KFC before, keep, flip, change. So what we've got is we keep the first fraction, so 11/9. We flip the second fraction, so now that's 4/3. And we change the sign from a division to a multiplication. So these two expressions here are exactly the same. Whenever we divide by a fraction, it's exactly the same as multiplying by the inverse of that fraction. And now this is a lot easier now. So when we're multiplying fractions, we can just multiply the numerators and multiply the denominators. So we can't simplify this anymore, so I'm just going to go ahead and do that. 11 times 4 is 44, and 9 times 3 is 27. So we've got our answer of 44/27. However, I am going to convert this back into a mixed number just because we've got a mixed number in the question. You probably won't lose any points for it because I can see it's only worth 2 marks, but I'm just going to do it anyway. So 44 over 27. 27 goes into 44 once. So how many is left over? Well, 1 times 27 is 27. So we've got 44. So let me just do 44 minus 27. So that becomes a 3, and that becomes a 14. 14 minus 7 is 7. 3 minus 2 is 1. We've got 17 left over. So it's going to be 17 over 27. That's my answer. 1 and 17 over 27. And like I said before, if you did put 44 over 27, you probably would get full marks for this one. Okay, part B, write down the value of 6 to the power 0. Now you should know, hopefully, that anything to the power 0 is always 1. So don't be confused about this. A lot of people will write 0 as the answer, or maybe 6, but it's always 1. So even if we had 700 or let's say 7003 to the power 0, well, that is still going to be 1. Okay, anything to the power 0 is always 1. Okay, and part C, write down the value of 5 to the negative 2. Okay, now whenever we have a negative power, we always do 1 over this number to the positive power. So what do I mean by that? So 5 to the negative 2. So whenever we have a negative power, it's always 1 over the base number to the positive power, 5 over 2. Or so 5 to the power of 2. So we just need to evaluate what 5 to the power 2 is, and that's 25. 5 times 5 is 25. So it's going to be 1 over 25. So that is my answer, 1 over 25. Question 23. Write 120 as a product of its prime factors. Give your answer in index form. Now I like these questions when we have to write products of primes. So we're starting with 120 and we need to break this down into its smallest parts. So we don't have to do it all at once. We can do it step by step. So I'm going to break this down into 12 times 10. 120 is the same as 12 times 10. Now if we focus on 12, 12 can be broken down into 4 times 3. So let's just color coordinate this actually, just to make it clear what I'm doing. So 12 is 4 times 3. And then we're going to multiply that by 10. And 10 we can also break down. 10 is not a prime number. 10 is 5 times 2. 5 times 2. So we have broken it down, but we're not quite done. So 3's prime, 5's prime, and 2's prime, but 4 is definitely not prime. So 4, let me just circle it actually. 4 can be broken down into 2 times 2. And then we've just got to multiply on all of these things. So times 3, times 5, times 2. So now we have broken it down into the product of its primes, but we haven't written this in index form. So I can see that we've got 2 times 2 times 2. Well, 2 times 2 times 2 is 2 cubed. And then we've got times 3 times 5. We don't have any more 3's or 5's. And we can't simplify this anymore. And this is in index form because our 2 has an index above it. So our answer is 2 to the power 3 times 3 times 5. And the order doesn't matter. So I've put it from smallest to largest. But if you did put 5 at the beginning, that's absolutely fine. As long as you've got these numbers, you will get full marks. Question 24. Rebecca is X years old. Mary is 8 years older than Rebecca. And Jill is 3 times older than Mary. The sum of their ages is 67. Work out Mary's age. So there's quite a lot going on here. But let's just do it step by step. So Rebecca is X years old. And Mary is 8 years older than Rebecca. So we can say that Mary is 8 years older than Rebecca. So it's going to be 8 plus X. Or you could say X plus 8. It doesn't matter which way around you put it. So Mary is X plus 8. So she's Rebecca's age plus 8 years. And then Jill is 3 times older than Mary. So Jill is 3 times older than Mary. So it's going to be 3 times whatever Mary is. And we know that Mary is, let me just box it. So Mary is x plus 8. So it's going to be 3 lots of x plus 8. So we can write it like this. So we can write it like 3 times x plus 8. Hopefully you can see what I've done here. So this is Mary's age. And Jill is 3 times that. So now we can simplify this. Jill is going to be, if we just expand the brackets, 3 times x, that's going to be 3x. And then 3 times 8, that is 24. So as an expression, Jill is 3x plus 24. And we know the sum of their ages is 67. So we can say that m plus x plus j, all 3 of them, are going to be 67. So when we add all of their ages together, we get 67. Now, at the moment, we've got m's, we've got x's, we've got j's. We're not going to be able to solve this equation, but we can write all of these terms, all of these letters in terms of x. So we know Mary is x plus 8. It's going to be x plus 8. And again, I think I'm going to colour coordinate this just to make it clear. So Mary is x plus 8. And then we've got plus x. Well, that's just Rebecca's age. And then we're going to add on Jill's age. Let's do Jill in red. Jill is 3x plus 24. 3x plus 24. And that equals 67. So now let's just go ahead and solve this equation. So if we simplify like terms, we've got x plus 3x. That gives us 5x. So 5x. And then we've got 8 plus 24. That gives us 32. And that equals 67. Now we want to get x, excuse me, we want to get x on its own. So if we get rid of this 32, if we subtract 32 from both sides, we're going to be left with 5x. These terms will cancel. And 67 minus 32 is 35. And now to get x on its own, we can just divide both sides by 5. And these 2 terms will cancel. And we're left with x is equal to 7. So we know that Rebecca is 7 years old. Be careful, that's not the answer. Go back to the question. It says work out Mary's age. Well, Mary is x plus 8. So Mary is going to be 7 plus 8, which is 15. So our answer for this one is 15. Question 25. EF and CD are parallel straight lines. So EF is this line here and CD is this line. So we can see they're parallel because they've got these arrows on. And we're told that CE is equal to DE. So CE, this length, is equal to this length. And we can again tell that by these dashed lines. And angle CED is 40 degrees, which we can see. So all of this information is actually just given to us on the diagram. We need to find the size of angle CEF. So let's draw that on CEF. CEF. So it's this angle here, which they've marked as X. And we need to give a reason for each stage of our working. Right, so there are a few steps involved here. We're given this angle here. We're also told that these 2 side lengths are equal. So that means that these 2 angles are equal. So we can say the angle ECD, let's do it up here, angle ECD is equal to angle EDC, but we need to give a reason. It says give a reason for each stage of your working. So the reason is, I'm just going to put in brackets, base angles of an isosceles triangle are equal. Base angles of an isosceles, I think that's how you spell isosceles, isosceles triangle are equal. Okay, now we can work out what these angles are because we know angles in a triangle add to 180 degrees. So we can say 180 minus 40, because this one's 40, so we can take 40 away. That will give us 140 degrees. And then if we do 140 divided by 2, because we know these are equal, that gives us 70 degrees. So we can say that these two angles are 70 degrees. Now, I'm not sure if I'm going to need to say this, but I will say it anyway. I'll write it down and say that angles in a triangle sum to 180 degrees, because we've also used that fact. So we can say, in brackets, I'm just going to say angles in a triangle sum to 180 degrees. So we've given two reasons now. Okay, now we've got this angle here, and next is key to see that these two lines are parallel. And angles, so let me just highlight this in a different colour. This angle in green here and this angle, there's a relationship between those two angles on parallel lines. These are called co-interior angles, and they sum to 180 degrees. Or actually, I'm going to do it a slightly different way. So instead of focusing on those two angles, I'm going to focus on this angle here and this angle. Okay, because these two angles also have a relationship, and these are called alternate angles. So what I'm going to say is that, and also alternate angles are equal, which is quite convenient for us because we're trying to work out what this is. So we can say that angle CEF, which is what we're after, well, that is going to be equal to angle ECD, and that is going to be equal to 70 degrees because we've just worked that out. So we've actually worked out what angle X is. Angle X is 70 degrees, but we need to give our reason again. So we can say that alternate angles are equal. Alternate angles are equal. Therefore, X is equal to 70 degrees. And that is it. So each stage, I've given my reasons for working out, and a lot of times there's different reasons you can give. So I mentioned alternate angles here. These two angles are alternate, but also these the angles before, they were co-interior, and you could have used that, and you would have also got 70 degrees as your answer. Question 26. Work out the shaded area. Give your answer in terms of pi. Right, so we're working out the area of this sort of ring around the outside. So what we can do is if we work out the area of the large circle, so if we work out the area, let's just shade this. So let's just imagine we've got two circles on top of each other. We've got this white circle that's on top of this red circle. So we're going to do the area of the big circle minus the area of the small circle, and that will give us this area here. So I hope you like my artistic skills in drawing, but hopefully I'm just showing you what I'm doing to get this donut looking ring around the outside. So how do we calculate the area of the large circle? Well, we've been given the radius of the large circle, and to calculate area, the formula for area is pi r squared. Hopefully you know that. So it's going to be pi multiplied by our radius squared. Our radius is 11, so it's going to be 11 squared, and 11 squared is 121, so it's going to be 121 pi. And I'm not going to try and work out what that is as a number. Obviously we don't have a calculator, so we can't really do that. So if we just leave it as 121 pi centimeters squared. So that corresponds to that over there. Now let's do the smaller circle. So the smaller circle, well, that is going to be exactly the same formula, pi r squared. So it's going to be pi times, this time our radius is 9. So 9 squared. And 9 squared is 81, so that's going to be 81 pi centimeters squared. So now we're just going to subtract this one from this one. So over here, that's going to be 121 pi minus 81 pi. And because these are both pi's, we can just take away the numbers. 121 minus 81 is going to be 40. So it's going to be 40 pi centimeters squared. And it says give your answer in terms of pi. Well, we have done that. So our answer is 40 pi. And we don't need to write centimeters squared because it is given to us in the answer. Question 27. Sally is raising money for charity for a fun run. And I have just done a marathon, so this is quite familiar to me. The table below has been given to her from the website. So we've got the donation amount and the frequency. So just to explain what this means here, we can see that 30 people donated between 0 and 5 pounds. So D corresponding to donation. There were 40 people who donated between 5 and 10 pounds, etc., etc. So Sally says the average donation is 10 pounds. By calculating the estimated mean, decide if you agree with Sally. Okay, now the reason it says estimated mean is because we can't actually calculate an exact mean. And the reason for that is because we don't know what the donations were. All we know is that the donations were in some sort of category. So these 30 people, they could have all donated £4, or they could have all donated £1, or some of them could have donated £1, some of them could have donated £3. We don't know. So we can't calculate an exact mean. So that's why it's an estimated mean. So what we do, the best way to, or the most accurate way we can calculate the mean is by using the midpoint. So I'm going to put another column up here for the midpoint. So the first category, between 0 and 5, we're going to assume that all 30 of these people donated £2.5 or £2.50 because we're going to use the midpoint. So let's just pick the midpoint for each of these categories. So the next one, between 5 and 10, the midpoint is going to be 7.5. The midpoint between 10 and 20 is 15. The midpoint between 20 and 50 is 35. And the midpoint between 50 and 100 is 75. So now we've got our midpoints. Let's calculate how much was raised for each category. So if each of these 30 people donated £2.50, what was the total amount raised for these 30 people? Well, we're just going to multiply. So we're going to do 30 times 2.5. So again, we can't use a calculator, so I'm going to just have to do this by hand. So 30 times 2 is 60. 30 times 2 is 60. And 30 times 3 is 90. So it's going to be halfway between 60 and 90, which is 75. Okay, let's do the next one. 40 times 7.5. So if I did 40 times 7, so there might be a better way of doing this, but 40 times 7 is 280. 40 times 8 is 320. So halfway between these is 300. So that's going to be 300. 15 times 15. Okay, 15 times, I actually know what 15 times 15 is, but it's 225. But let's just, the way I would probably do it if I didn't know would just be to do long multiplication. So 5 times 5 is 25. 5 times 1 is 5, plus the 2 is 7. And then put a 0 because we're working in the tens column. 1 times 5 is 5. 1 times 1 is 1. Add them together and we get 225. So 225. And now we've got 35 times 11. The way I would do this is 35 times 10. 35 times 10 is 350. And then we're just going to add on another 35 because we've got 11 of them. So that's going to give us 385. 385. And finally, 4 times 75. Well, funnily enough, 4 times 75 is exactly the same as 40 times 7.5. So that's going to be 300 as well. So that's 300, not 360. Right, so now we've got the total donations for each category. So to work out the grand total, we can just add all of these together. And I can just add them up in columns. So 5 plus 5 plus 5, that's 15. 7 plus 2, that's 9. Plus 8 is 17. Plus 1 is 18. And then 3 plus 2 is 5. Plus 3 is 8. Plus 3 is 11. Plus 1 is 12. So that is the total amount raised for Sally. And to work out the mean, we just need to divide this total donation by the number of donations. So let's just write this down. So mean is going to be total donations divided by number of donations. That's how we calculate the mean. So the total donation is 1,285. The number of donations, we're just going to have to add up this category here, so the frequency category. So this is 70, 85, 96. Oh, that works out quite nicely. That's 100. So there are 100 donations. So 1285 divided by 100, that's going to be £12.85. So that is an estimate of the mean. So it says, decide if you agree with Sally. No. Sally is wrong. And we could just say estimated mean equals £12.85. So yeah, she's quite a bit wrong. She's about £2.85 off. Obviously, the average, the mean could be £10, because we just don't know what the donations were. We only have to calculate an estimate of the mean. So we're going to say no, she's wrong based on the fact that £12.85 is not £10, quite clearly. Question 28. Here is a rectangle. All measurements are in centimetres. Work out the area of the rectangle. Right, so we've been given expressions for each of the lengths. So how do we calculate the area of the rectangle? So the area of the rectangle, we do base times height. But before I do that, we need to calculate what these lengths are. At the moment, we're not told what they are. We're only given expressions for the lengths. But one thing I know about rectangles is that opposite side lengths are equal. So this side length and this side length are equal. And this side length and this side length are equal. So what we can say is we can say that 11x minus 2, let's do it up here, 11x minus 2, well, that is equal to x plus 18. That is equal to x plus 18. These two side lengths are exactly the same. So now we can just solve this equation. So to solve this equation, I'm going to put all of the x's on the left-hand side and all of the numbers on the right-hand side. So if we subtract x from both sides, we're going to be left with 10x on the left-hand side. Minus 2 is equal to 18. These two x's will just cancel. And then if I get rid of this negative 2, if we add 2 to both sides, we're going to be left with 10x on the left, and on the right we'll be left with 20. So 10x equals 20, therefore x is equal to 2. So now we've got x, now we've got our value for x, we can just substitute this in to some of our expressions. So if x is equal to 2, let's just put 2 in here and 2 in here. We're doing base times height, so we don't even need to worry about these expressions anymore. So 2 plus 18, this side length is going to be 20. And this side length is going to be 2 times 2, which is 4. 4 plus 1 is 5. So the area is going to be 20 multiplied by 5, which gives us 100. And all measurements are in centimetres, so that is centimetres squared. And again, if it didn't say centimetres squared, make sure you write your units. But for this one, we don't need to. We can just write 100. So hopefully that made sense. So the first thing to do was to identify opposite side lengths being equal in a rectangle and making an equation so that you can then solve that equation to get the value of x and then substitute that back in to your expressions to get the actual values for the side lengths. Question 29. Max is drawing the graph of this equation here. And he's got his table of values and then he's plotted his table of values onto a graph. Write down one thing that is wrong with Max's graph. So we only need to find one thing. Now, straight away, looking at the graph, I can see that this looks quite nice and even, but then this one seems to be a bit out of the way. So I'm going to focus on this one first. So this is when x equals 3. So that is this one here. So when x equals 3, what is the value of y? Well, let's substitute 3 into our equation. So we've got x squared, so it's going to be 3 squared plus 2 times x, so plus 2 times 3 minus 6. So 3 squared is 9, 2 times 3 is 6, minus 6, so 9 plus 6 minus 6, well that is just 9. So when x equals 3, y equals 9, and it does look like that is correct. So that one is fine, so maybe my eyes are deceiving me. Okay, let's take a look at this one here. Because now on second inspection, I think this one might be off. I think this line might be going something like that. So this one might be off. So let's do exactly the same thing with 1.5. Oh, actually, looking at his graph, look at now I've just seen this. This is on 1.5. He hasn't even found 1.5. He hasn't used 1.5 as his value for x. So I think this should probably be at 2. So when x equals 2, y equals 2, which would be here. So let's just check that. So let's substitute 2 in. So we've got 2 squared plus 2 times 2 minus 6. So 2 squared is 4. 2 times 2 is 4 minus 6. 4 plus 4 is 8. 8 minus 6 is 2. So he was correct in his table of values. That is correct. But as he's plotted it incorrectly. So he's plotted the x value as 1.5. So we can say that when graphing, he has plotted his x value for 2 at 1.5. Something along those lines. It doesn't need to be word perfect, but as long as the examiner can see that it relates to this point here and it should be shifted over to here, that would be absolutely fine. Question 30. The population of an island has decreased by 40% over 50 years. The population in 2018 was 360. Work out the population of the island in 1968. So notice 1968 is 50 years before 2018. So let's write this down. So 2018, or not 2100, that's in the future. 2018, the population was 360. And in 1968, we need to work out what the population was. But notice it says the population decreased by 40%. So whatever it was in 1968, it decreased by 40% to 360. So this 360, that represents 60% of the original population from 1968. Because if we think about it, if we're decreasing by 40%, well, this value is 60% of the original value. So 1968, another way to think about it is 1968, that is what we're starting at. So that represents 100%. And in 2018, the population has decreased by 40%. So we're now at 60% of the original population. So we can say that 360 people, that represents 60%. So we want to work out what 100% is. This is what we're trying to work out, what the population was in 1968. So we need to work out how many people represent 100%. So the way I'm probably going to do this is first of all work out 10%. So to go from 60% to 10%, I'm just going to be dividing by 6. So 360 divided by 6, well, that will give me 60. And then to go from 10% to 100%, I'm going to multiply it by 10. So if I do exactly the same on the left-hand side, if I multiply by 10, that will give me 600. So the population in 1968 is 600. And let's just reason our way through that. That does make sense because we know the population was higher before. So the population started off at 600 and it decreased by 40%. So it's gone down to 360. So that does sound about right if we reason our way through it. So my answer is 600. And that was the last question in the paper. Question 30 was the last question. So hopefully you got on quite well with that, and hopefully it was useful in your preparations for your upcoming maths exams. I am going to do 2 more exams, 2 more walkthroughs for the foundation tier. So I'm going to do paper 2 and paper 3. And I'm also going to be doing the higher tier as well. And just to let you know, I have got many more of these walkthroughs on my channel. So if you go to the GCSE walkthrough playlist, you'll see loads more of these. So I encourage you to go through those papers because the best way to revise is just to keep doing past paper over past paper. So thanks again for watching, and hopefully I'll see you for paper 2. Take care.